Hello. In this video, we're just going to clear up a bit of confusion that sometimes happens when people are doing minimums and maximums. So let's go look at the problem we have here. A company is looking to break into the 5-cent candy business, and they want to maximize their profit per day. Recall that profit is equal to revenue minus cost. Now, the revenue function is modeled by the following. Revenue equals 5x, where x measures the number of candies sold in groups of 100. That's pretty obvious because if you sell 100 candies, you make 100 times 5, or $5. So we have 5x. Now, an expensive consultant determined that the cost is modeled by the function 3x squared, or 3x to the 4 minus 28x cubed plus 84x squared minus 91x plus 32. Now, each one of these terms means something different, so each one stands for something. We can't really draw a diagram here, but thankfully our expensive consultant has figured out the formula for us. Now the question is, of course, determine the optimal number of candies to produce. We want to make the most money possible while we're breaking into this business, and so let's see what our optimal value would be. Well, profit is what we want to maximize, and profit is equal to, if you see, revenue minus cost. So 5x minus 3x to the 4 minus 28x cubed plus 84x squared minus 91x plus 32. So if we distribute that negative and go ahead and look at the 5x and the 91x, we'll be able to group those together. So we'll distribute the negative first. 5x minus 3x to the 4 plus 28x cubed minus 84x squared plus 91x minus 32. So the 91x and the 5x can be grouped together, so we'll do that, and we'll put everything in order from highest to lowest. So negative 3x to the 4 plus 28x cubed minus 84x squared plus 96x minus 32. All right, well, our goal is to find the maximum, which means we need to do a derivative. So we're going to get negative 12x to the 3 plus, well, 28 times 3, that's going to be 84x squared minus 84 times 2. That's 168x plus 96, and the 32 is gone. Now I'm going to help us with a little bit of factoring here. There's a negative 12 in common with all of these terms, so we'll get x cubed minus 7x squared plus 14x minus 8. We need to keep factoring, and we need to find the nice simplified version so we can do our work. And, well, here we probably need to use a little bit of synthetic. So let's try working, maybe the roots are going to be plus minus 1, plus minus 2, plus minus 3. Let's try 1. That's a nice easy root. So if we had x equal to 1, we could just test it here by plugging it in. So 1 cubed minus 7 times 1 squared plus 14 times 1 minus 8. Well, that'll be 1 minus 7 plus 14 minus 8. Oh, looks like that's actually going to work out quite nice for us. That's just going to give us 0. So when x is equal to 1, we could say p prime of 1 is equal to 0. Well, maybe you were a little bit lazy or a little bit tired today. You didn't really want to do the actual synthetic with this. You didn't want to factor it down, and we'll have to find 2 more roots after. So you know what? Maybe you just call it good. Maybe you say, every time I've done a min-max problem, when I find the x equals 1, when I find the critical point, I know that that's the maximum, and so I'm just going to call it good there. So we're going to make what I would consider to be here a pretty big assumption. It may end up being even a mistake, but we're going to go with it. And we're going to say that the max profit is at x equal to 1. We're not going to do a sign diagram. We're not going to do any factoring. We're just going to call it there. Because some of you might be feeling like, oh, all that factoring and sign diagram business, it just tells me what I already know. That when I get my critical point, that is my maximum. Well, let's actually find what the profit is. So we'll find p of 1. So that'll be negative 3 times 1 to the 4 plus 28 times 1 cubed minus 84 times 1 squared plus 96 times 1 minus 32. So we'll get negative 3 plus 28 minus 84 plus 96 minus 32. So let's try to work at this 96 and 84 together. That'll give me 12. So negative 3 plus 28 plus 12 minus 32. Now negative 28 and 12, or positive 28, sorry, and positive 12, that'll be positive 40. And so we get 5. All right, so our max profit is $5. And this occurs when the company produces one group of 100 candies. And well, I guess that was candies per day, maybe we should say. One group of 100 candies per day. And it might be tempting to call it there. That's going to be our maximum amount of money we could make, produce one group of candies, and there you go. But it just feels a little bit hasty to say that x equals 1 was our maximum. Let's go back and let's just confirm that that was indeed the case. So let's do our factoring here. We had x cubed minus 7x squared plus 14x minus 8. So let's do synthetic there. 1, negative 7, 14, negative 8. So we're going to get 1. That's going to give us 1, negative 6, 8, 8, and 0. So we get x minus 1. X squared minus 6x plus 8. And then it looks like we could factor that further, so that'll be x minus 4 and x minus 2. So let's take this and go back to what we were working on. So over here, we had our p prime. And we didn't factor this before, but let's factor it all the way now. So we'll get that p prime of x is equal to, we've got that negative 12 in front. We've got x minus 1. We've got x minus 4 and x minus 2. Well, let's go ahead and do a sign diagram. So we've got 1, 2, and 4. Pick a number bigger than 4, say 10. We're going to get negative because of that negative 12. Positive, negative, positive. Now clearly we can't have anything less than 0. So all this stuff over here is not going to be in the domain. Couldn't produce negative amounts of candy. But let's look at that sign diagram. Increasing, decreasing, increasing, decreasing. Oh, interesting, interesting. It appears that while x equal to 1 is a rel max, there's another rel max at x equal to 4 that we didn't see. Now there's a rel min at x equals 2, but who would want to find the minimum amount of money to make? That's not a good idea. But it looks like x equals 4 is a possible value for the maximum. And since we have two rel max, we need to compare them. Compare p of 1 and p of 4. We need to see which of these is actually the highest profit, because the graph might have both of the hills at the same point, or one of the hills might be higher than the other one. So we're going to need to do a little bit more work here. So for reference, we found that p of 1 was equal to 5. Let's go ahead and find p of 4. Well, that's going to be a fair amount of work to plug in. We have negative 3 times 4 to the 4 minus 28 times 4 cubed plus 84 times 4 squared minus 91 times 4 plus 32. So if you work all that out, and I would understand if you use a calculator on this, if you work all that out, you're going to get 32, which means that we are actually making more profit if we make 4 groups of 100 candies than if we just make 1. We have $32 of profit. This is much better. So the actual answer is p of 4. The absolute maximum is 32. So the company should produce 4 groups of 100 candies per day. Now, it's very unlikely you're going to get a question like this on the test or the exam, because usually there's just going to be one relative maximum or minimum. That's your point, you're good to go. But this question shows why we have to do the sign diagram, why we have to factor all the way in, why we have to put all those roots down. You might feel like it's a bit of extra work and it's not really necessary, because once you find the one critical point, you're good to go and that is your answer. And 9 times out of 10, or maybe even 99 times out of 100, it is true. But it's not true in general. In general, you need to check all of the relative maximums to find out which one is the absolute, and you need to draw a sign diagram to ensure that the critical points you're looking for are actually absolute maximums instead of maybe absolute minimums. And so I know it might seem like extra work, but please make sure you always draw a sign diagram and you always provide a justification for why the point you found is indeed the point you're looking for. So I hope you enjoyed this video, and until next time, thanks for watching.